Hello everyone, and welcome to my video. And before we start, let me introduce myself. I've been developing for over 10 years now, and mostly JavaScript, but also been a Rust developer for the last year and a half. Now we're developing backend for our company's mobile application and other services. And when I have time, I try to keep my notes about development services on my personal blog. The first question, person familiar with this technology may have is what is assembly. WebAssembly, or short, is an innovative technology designed to accelerate web applications. WASM is a binary instruction format what allows code written in various programming languages such as C++, Go, and Rust to be run directly in the browser. This code achieves near native performance, making WebAssembly a key tool for development modern web applications. Whereas developers should pay attention to WebAssembly, and first of all, utilizing our existing skills. As I think almost everyone watching this show knows, Rust is a powerful system programming language, known for itself for its security and performance. With assembly, Rust developers can use their expertise to create high-performance web applications, what were previously only possible using JavaScript. The next point is improved performance. WebAssembly allows you to execute code much faster than JavaScript. This is especially important for computer-intensive applications such as games, graphic editors, and simulators. Rust in turn provides high-performance code, what is ideal for compilation into WASM. Next point is the cross-platform. WebAssembly works in any modern browser regardless of platform. This means that application written using WASM and Rust can run on any device, from desktop computers to cell phones and tablets. For clarify, I provide screenshot from caniuse.com to see a list supported browsers. This technology is not supported by only Internet Explorer. And will be honest, for last few years, I've only heard about them in conversation with other developers. Even Microsoft itself has long since switched to Edge browser for a long time ago. What is WebAssembly? WebAssembly, or WASM for short, is a binary instruction format for a stackable virtual machine, designed for efficient execution in web browser. It allows programs written in a language like C, C++, Go, or Rust to run in the browser at near native speed. It complements JavaScript by providing high performance for computationally complex tasks like games and applications that require multimedia processing. It's an open standard supported by a major web browser, what facilitates for creation of faster and more powerful web application. To simplify the whole process, it goes like this. The source code is compiled into binary WebAssembly format, which is then loaded and executed in the browser. WASM models run in isolated environment, but can interact with JavaScript, allowing them to integrate into web applications. And the future important note, WebAssembly complements JavaScript, not replace it, and allow developers to choose the best tool for the task. Why we should Rust WebAssembly? And first of all, it's performance. Rust as a system language provides efficient memory management without garbage collector. When compiled into this yields code that runs almost native application speed. Next point is safety. Rust ownership system guarantees memory safety without additional runtime overhead, which is ideal for WebAssembly where every millisecond is crucial. Next point is compatibility. With the help of libraries, I'll talk about them a little bit later. Rust integrates nicely with current web application ecosystem and provides fairly easy interaction with JavaScript. As I mentioned in the last slide, Rust has advanced ecosystem of tools, as well as excellent WebAssembly support at the Rust compiler level. Where to use? Projects written in various programming languages will be mentioned here. And first of all, it's games. The first thing what might come to mind is games. As far as I'm concerned, we're always been engine of progress. And of course, Doom was run in browser using WebAssembly. Also now quite popular various simulators of game consoles, from a time when grass was greener and the sky was blue. Next point is the computational task. WebAssembly is ideal for performance complex computational tasks, such as working with neural networks, which require fairly large computational. For example, well known is Unit Circle's TensorFlow library has support for WASM. And next point is multimedia. As I mentioned above, WASM allows us to work with large amount of data faster than JavaScript. Therefore, we can perform some video operations such as adding a filter to a video without uploading it to a remote server. Graphic authentication. For example, we can calculate data for complex and large graphs, especially if data appeared on the client side and did not come from server. And much more. To be honest, applications of this technology are limited only by ourselves. This can be various kind of cryptography. For example, you can make your own encryption, which is not so supported by browsers, as well as various types of archiving or unarchiving, and it's not possible to optimize code fragment, what requires large calculations. On the next few slides, I'm going to say about few useful libraries and techniques which used in WebAssembly with Rust. And first and foremost thing we will need to work with WebAssembly is WASM binding library. It's a basic tool for linking Rust and JavaScript and generated code. Next is JSCs and WebCs. These libraries provide bindings for built-in JavaScript APIs and browser APIs. We allow our code to interact with them, execute network requests, and utilize our browser features. The next important question is what types of data can be transferred. These can be simple types such as numbers, strings, and the Boolean values. There also can be more complex data structures such as object or structure or whenever you want to call it. Through serialization further. Next point is async operation. It can be also various async operations such as promise, async await, or event model. Performance. Last on the list, but not less important, it's performance. Try to minimize communication between JS and WASM to optimize processes and use share a buffer for more efficient memory sharing. And I think we're ready to build our first WASM application, and first what we need to do is preparation. I think most of us have Rust on their computer, and so I won't focus on it so much. The only thing we need to do is add a target for WASM with next command. This will allow us to compile our code into WebAssembly for execution in the browser. We also need to install WASM pack library to build our project. And let's start now we can get on with project itself. Create a hello WASM library and go to create a directory. Here we need to specify type of library. It doesn't work without it. And add WASM binding to dependency. The current version is 0.2. Now we can finally move on to writing code, and I decided to follow tradition and make flow application to begin. The first thing we need to do is import necessary dependency. When we use derive WASM to specify with compiler what this function should be available in WASM and actual code in the function itself, and create a HTML page where all WebAssembly magic happens. I want to focus on how it works right now, and I'm going to do it a little bit later. Next, what we need to do is build our application. It goes with one command, and you will have release version if you not specify otherwise. If command work without errors, we could see the following files in the root of project. 2 files with extension d.ts. It's necessary for correct work of TypeScript and typing for it. Hello.wasm, which contains all necessary wrappers for working with our application, and hello WASM BG, which actually is our application. And, we're ready to run our application. And I used this command line for static web server, but you can use command convenient for you, for example, serve. And the result of work in our application. I now propose to go through assembly tools used. This is WASM pack, and where is what's it give us? Simplified build procession. WASM pack automates the process of building and linking Rust code into WebAssembly, simplifying development and reducing bugs. This is WASM pack, and here is what it gives us. WASM pack automates the process of building and linking Rust code into WebAssembly, simplifying development and reducing bugs. Generating PM-compatible packages makes it easy to distribute and use WebAssembly models in JavaScript projects. Automatically generates TypeScript types for exported function, which is easiest integration and improves type-driven development. The second package is WASM binding. WASM binding simplifies integration of Rust code with JavaScript by providing convenient tools for linking functions and types between these languages. Also, this package supports serialization and deserialization of complex data types between Rust and JavaScript, making it easy to transfer data between these environments. And generates the necessary linking code, which saving developers from manually written wrappers to communicate between Rust and JavaScript. And now let's speak about optimization libraries and some practice. The first library will be WASM opt. It significantly reduces size of compared to WebAssembly models, which reduce load time and web application performance. Code optimization can improve performance of WebAssembly models by removing unused code and optimizing of excess codes. Also, WebOps provides different many type of optimization, and such as remove unused function, inline compression, and other techniques. Next library will be valog. Use valog minimalistic memory allocator to reduce size of binary file and add it to your project. All what you need is add it into your project and call in the code. In example below, the file size will be reduced to almost 3 times. Next library is Twiggy. Twiggy is a tool to analyze the size of composition of your WASM model. Unfortunately, I can't say much about it, as I haven't chance to work with it yet. Optimization of JavaScript. The most common ways to optimize on the JavaScript side to reduce the number of WASM code calls and try to pass every what you need in at once. Or also we can use sharp array. Integration with JavaScript. And let's dive to integration with JavaScript. And first what we need to discuss is import and call. Before you can call anything in WASM, you need to create it. If you build a project, you will have required files in a package directory. We need to import file nvchance.js, and after we have built the project, we will have required files in a package directory. We need to import hello wasm.js file. There are 2 functions imported here. The first is init, which we need to connect WASM file to our code, and the function greet, which refers the function, and the function named greet, which refers to a function we have written in Rust. We start working with WASM, we need to call init function, and after the function works, we can start calling our methods. Data transfer. Here is an example of obtaining basic data types such as string, number, or boolean value. And how to pass these params into our code. Let's now take a look at interaction with the DOM. In this example, we will read that data from input, add it to the page, and clear the input. Now take a look at interaction with DOM. In this example, we will read the data from the input, add it to the page, and clear input. First, we need WebSys library. To access DOM, we need to get a document which contains whole tree. Next, we need to find the required input, gets its value, the div to which we add value obtained earlier, and add this div to DOM, and clearing structure. To work with structure in JavaScript, we need to first of all define our structure and WASM backend for it works. Now let's make implementation of a constructor. It should be marked with special derive for constructor. The public methods which are necessary for reading and writing. On the website we import created structure and call it via new. Output data for reading and add some changes for into our structure. Try catch error. We catch an error what could occur on the side of WASM. I have special method here what returns an error. On our site everything works for usual result. On website we need to wrap a call function into try catch construct. Integration with accessor projects is nothing complicated, and the file is easy to get regardless of framework you're using, or it should work as well with React, Vue, whichever frameworks. Now a little bit about limits and how we can struggle with it. WebAssembly binaries can be quite large, and it increases with download time and the amount of data transferred. This problem is solved by removing unused code and various techniques described above. Next point is debugging. Debugging WebAssembly can be difficult, especially due to lack of detailed error message and limited tool support. Use WASM backend to generate source map, which help link WebAssembly code with original Rust code. WebAssembly has limited support for some web APIs, which can complicate interaction with DOM and our browser functions. Use WASM backend, JSCs and WebSys libraries to access the necessary APIs and create convenient interfaces for interaction with JavaScript. In case WebAssembly doesn't support required APIs, use intermediate JavaScript to interact with WebAssembly. Despite its high performance, WebAssembly can encounter delays when interacting with JavaScript, especially in scenarios with frequent function calls. Minimize the number of calls between WebAssembly and JavaScript by combining them and, when possible, applies code to reduce expense operation and use efficient algorithms. Support for multithreading in WebAssembly is limited and requires additional customization. We can use web workers to perform multi-threaded tasks and coordinate their work using messages. Rust and WebAssembly are a powerful combination for building advanced web application. Using them together, you can realize your wildest ideas. And you will know limited of anything. As I said somewhere above, the possibilities of WASM are quite, and how you use them, that's up to you. Thank you for spending time with me, and I hope you learned something new. Bye.